So now I'm going to talk about the 2583 and the 2584 LNAs. Both of these LNAs were designed for our Vita X solution. But in the meantime, while we wait for Vita X to come along, we have these two products that are centered around 5.95 gigahertz. Both of them are DFN6, which makes them very interesting to try to tame tuning wise. Both of them are two-stage LNAs, so they have higher gain than our 2070 and 2080X brand of LNAs. The fact that both these parts are two stages means they both have an interstage that we have to deal with, meaning the drains are separated. We can apply voltage to the drains of both stages, and we do that through an interstage, which is typically on pin 6 of our DFN6. The stability issues can be significant in the initial stages of tuning a device such as this, but we have hooks and we have methods to tame these parts. I think the 2584 has slightly more gain than the 2583, and the main difference between the 2584 and the 2583 is the 2583 has the ability to turn off and bypass the second stage. So the 2583, you have a high gain mode and a low gain mode. The 2584 is just both stages on, and you just have one gain mode. The 2584 is much more friendly for tuning, and I think it's because there's something going on with the weakness of the isolation on the bypassing of the second stage on the 2583. So for that reason, our 2584 so far has gotten more traction. I believe the 2583 still has some more work to be done on tuning it, but we do have a good standard tune where the part does work pretty well in its native frequency domain, which is 5.95 gigahertz. For the 2584, I've done tunes down to 3 gigahertz. I've done tunes up to 9 gigahertz. You can kind of put a disclaimer around those frequency ranges. The performance does drop off, and it's hard to maintain the native performance. So you're definitely gonna gain noise figure. You're gonna lose linearity. You're gonna lose power at the higher frequencies. The good news is, as you go lower in frequency, the noise figure gets better. Even at 5.9 gigahertz, our noise figure, de-embedded noise figure on these devices is around 1 dB. And I think that's pretty dang good for being almost 6 gigahertz and having almost 30 dB of gain. So going down in frequency, I think you have an improvement in the noise figure, a little more power, and the gain kind of stays where it's at. It stays between 25 and 30 dB. The 2583 so far is not friendly to too many tunes outside of its native band. We have tuned it down to around 5 gigahertz, and on the upside maybe around 6.5. One of the limitations, I believe, is the eval board that we have available for the 2583. I think it needs its own special eval board. It seems to respond really well when you can connect the two drains as close as possible. And I've done this by using a large shim or a large jumper above the second stage choke inductor, jumping it straight over to the interstage stage 1 voltage input. That really allows the part to respond better to tuning up and down in frequency. Whereas the 2584 is the easier child of the two parts. It behaves very well. Another thing about the 2584 and 2583, they have a internal DC blocking cap on the input. So you only need to match the input after the implied internal DC blocking cap. So any type of shunt component on the input won't affect any type of voltage. The IP3 on these parts isn't as good as our 2070, 2080X parts. It's around 32, 33 dBm. P1dB is around 16, 17 dBm. These parts are not designed to be high power linear parts. They're simply, for the frequency range they're at, around 6 gigahertz, they're designed to be low noise and have high gain, and to be stable. These are the key features of these parts. So in our environment, we only have the knowledge from tuning previous types of parts. So as new products are introduced into Guerrilla RF, there's always a learning process, and the learning process never ends. I see parts we tune that have been released for years, and we find new hooks and new ways to improve them. It's just the nature of the industry that we work in. So the 2584 and 2583 being very new products, and since I started working at Guerrilla RF, these products were pretty much brand new. No one had really touched them before me. All I knew was to tune on them the way that we've tuned on other products. And to be fair, some of the early tuning was pretty messy and pretty choppy. Come to find out, simply changing your RF in, RF out in your interstage tuning to 0201 form factor components from 0402, what you gain is a huge reduction in these parasitic resistance and inductances, especially through the capacitors. That allows the part to, especially S parameter wise, smooth everything out. We saw a great improvement just by switching from an 0402 SMD to 0201. By switching to the 0201s, I saw a big improvement in mu stability. It was already at or just at 1. Now it seems like it improved higher above 1. Also, we saw little resonances in our S22 and our S11 where there was little spikes in gain in a positive direction in S11, which is not desirable. But just by switching to the 0201, these artifacts disappeared, and now you just have a much smoother contour through all the S parameters. For the 0201 components, I use the same existing board that we already have. Unfortunately, that board is laid out to use 0402 components. So right now we have a request in to redesign that board and make the pad sizes for the SMD matching components to be 0201 instead of 0402. I believe that once we have that new board in, the overall performance should improve slightly even better. Another benefit of using 0201 matching components is the form factor. The form factor being smaller means you can now bring everything in closer to the DUT, meaning when customers lay out their PCB integrating our 2584, 2583 products, your footprint now is shrunk. It's a lot smaller. I think that's a big advantage, being that all of our products mostly are discrete, meaning we don't use internal matching. You have to match it externally. In discovering and adapting 0201's SMDs to the 2584, 2583 products, we've discovered that Using the 0201s and other packages and other products like the 2176, for example, seems to greatly improve the look of the S parameters. So way less blips or nonconformities are appearing. So I think anything that's a DFN6 package seems to be benefiting from the lower parasitic matching components. And not to mention now, obviously, people can shrink their footprints for integrating our components into their applications using the smaller SMDs.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.